want to watch it. So today we'll be talking about loops. Okay, this is one of the I guess most important features in any language. Again, I cannot imagine writing a program without loops. Okay, especially now we have tons of data. It's really important. About Python, as you'll find out that Python has only 2 loops, and that's it. It is no other. So, which is good in a way that you don't have to worry about so many loops. It's bad because it doesn't have enough loops, right? So it has just the while and the for loops, and that's all you have to worry about. Because some of the stuff are already built into it. Like when we learn about lists later on, you see that it's already built into lists. It's built in loops already, and so a lot of this stuff are kind of redundant. So you're not going to have like the do loops like you would see in other languages, or the for loops. The for loop in Python is like it's almost like a marriage between the for loop and the for each loop. All combined together. It's depending on how you use it. Okay, because one is you can get the key, one is you just get the value. Whereas like a Java or JavaScript, you have the regular for loop, and you have the for each or for and loop. Okay, so a little bit different there, but Python just 2 loops and you're done. And sometimes less is better, but those are. I think it's good enough. It's enough to get things going. So let's look at the loop here. Look at the while loop first, okay? And I'm not gonna go into the reading here. I'm sure you've already read it yourself. But just look at the syntax really quickly, and you'll see that it's very similar to where's that? Very similar to the other loops, other languages as well. Yeah, this book is not really. They should put the while loop right away, but. Well, anyway, I'm just going to go right into Spider and let's do it. It's pretty straightforward because now we know about the conditions, we know about the decision structures, and so it's a good segue. You could get right into loops because you're using loops a lot, and also the if and else and a lot to do your code. So I'm going to go ahead and create a new project in here just to organize our work. So again, go to Projects, New Project, and this is going to be Unit 4. Is it 4? Close this. All right. So, File Explorer. I'm going to create a new file, a new Python file, and I'm just going to call this one while loop.py. I don't like this screen. It's really tiny. It must be the resolution of my screen here. It gets smaller and smaller. Even I can't really see it on my laptop. But the screen is actually a little better. Okay, so let's look at the while loop. The while loop here is, in the Python, is always what's called a top control loop. This is the while loop. A top controlled. You hear this term in some other languages. Or sometimes we call it the pre-test loop. Okay, because you test the loop, you test the condition first before you actually execute the body of the loop. So that means it's not guaranteed to run the body of the loop. Okay, it may not run. So the syntax for the while loop is pretty simple, just the word while, followed by the condition. You want to test. You always test the condition, and put here just the condition, and then followed by your colon character. And then the body of that while loop. Now, inside here is the condition. You'll see that in the book and many other places. Most people, when they code it, they don't use parentheses a lot in Python. And but it's sometimes good to use it. It's not wrong to use it. It's just you just use 2 extra bytes of data. Okay, we have a lot of conditions. It's useful to put them there. It just makes more sense. But the condition goes there, so we'll just follow the one in Python. Would be whatever that condition is, and it's the same rule as we do the if and else statements, right? So the condition will always be evaluated to true or false. That's it. There's no other data here. It's always going to be true or false. And so if you put something like this, true, then of course it's going to be true. Now, in order for that while loop, the body of the while loop to run, this condition must be evaluated to true. Okay, the result has to be true. The actual data in there may not be true, but the result has to be true. And sometimes you see that it gets a little bit tricky, but the overall evaluation result should be true. If it is so, then we'll put something in there. And if it's true, then let's just say we print something. It's true. Okay. So be very careful when you do something like this, especially if you just say true like that and you print that statement, right? Because it's going to run infinitely. You have the infinite loop, never ending, forever loop, la la la. So be really careful when you do that. Then if you want to pause it, then you have to do something. Either call it a break to break it, so break out of that loop. The break will cause a stop, a premature termination of that loop. Okay, so in this case, that's fine. Sometimes you want to use that true, especially when you want to read something from the input until a certain value is read, and then you terminate the loop. Okay, so sometimes it's easier to do this way. So if I do this and I click run, and you see that it prints that statement is true only once because we put the break right there right away, right? So you can break out of a loop this way. And we'll talk about infinite loop in a little bit here. So I just want to show you one thing here. I'm not sure if we talked about this before, but you can see that if I don't put anything there, okay, right? If you put while true and then you skip that thing, and then you put a print statement in it separately. Let's see, like that, and you see that you're going to get an error. Yeah, this is true for usually every time you do anything we have a colon. Okay. After that, if you don't indent your code, the next line, it doesn't have to be the next line. From that until the next statement, if there's no code in there and you don't indent your code, you're going to run into an error. It's a syntax error. Okay. So you must put something in here. Even if you want to put anything there at all, since you use that colon, you have to put something there. Either a print statement, even a break, or the correct way to use it, if you want to do anything with it, just put the word pass, and that will ignore that block of code. Okay? I mean, just pass through. So that continue my code and so forth. So you see that sometimes in other people's code, when they write some function or a if block or something, there's nothing there, just pass it. And this is usually very useful for when you debug your code. You don't want to print any data. I just want to test if my loops work or my conditions work, right? So put pass, and that's fine. But then, because with pass, you don't know exactly where it works or where it doesn't work. So you still have to put flags in there. But I just want you to know that it's important to always have something there after the colon. Okay. So that is a condition, because that condition is already evaluated to true. So there's no evaluation going on there. It's already true. So we put break here, right, to keep that, to stop that. And just in case if you don't, then you see that it prints forever. Okay, and eventually, if I leave it on like that, it's going to crash my program. Okay. So very luckily, we're able to use this IDE so you can terminate that loop. Otherwise, yeah, you'd be in trouble. So that is a very simple while loop. And then something a little bit more feasible would be something like this, and then you test the condition. What is the condition? Will be like same thing like this. Again, this will be the same as above. You put break here, right? The difference is that this is always already true. This one has to be evaluated first, right? And then resulted in the true or false case. Okay, let me check something here. I think I'm not sure if they can still see it. Let me try one more time. For some reason, I think it stopped sharing. Okay, here we go. Okay, I hope you guys can all see. Yeah, there should be audio. Okay, so so this is a condition. This is called a true V or false V condition, right? Because you always evaluate it to get it either true or false. And so that's kind of the same thing. Again, be very careful because it can lead into the infinite loop. Something more practical would be something like you're reading input from data. And I'll show you this one here. It's called the using a signal. A signal is nothing more than just a special character that you can use to terminate a loop. Notice I used the break to terminate the loop there. A signal will be like any value that you can use to terminate a loop. So let's say, for example, I want to keep asking the a user to enter a number until it hits a special number, I guess the magic number, right? And you can always do something like this. So let's just say that my magic number is 7. Okay, that's my magic number, and whatever they enter has to match my magic number. It's a pretty, a classical game. Guess my number. So you can output a message something like this. I'm going to read that data to a variable called guess. and you can say input here. Enter a number, or you can say, what's my magic number, right? Reading as an integer, so you want to convert this to integer first. You can do it right away here, or you can do it afterwards. I prefer just do it right here. Do you remember how to convert to an integer? Very simple with Python. This is like the simplest, because you just put the int here, and then you wrap it with at the int function, and that is now an integer. So very, very easy. Like if you would C# or Java, you do like convert to int something something. And then once I get that, then I can do a while, and you can say while couple of ways, right? One way is you can use the true like I did earlier. You can do that. And then you say, while it's true, this is ongoing until the signal is reached, which is the number 7. I guess you can use that as a signal. Usually it would be something different, but that's the same thing. You can check if the number, the magic number, is equal to the guess number. Right? If it's true, then we can say you found it. We can print congrats, and then we can end that program. We end it again. I used the break here earlier, right? You can break it out. If it's not true, then you can put the else part. But since it's going to be false, you don't have to care about the else part. It's going to be the else anyway. So usually you say, okay, if that's the case, then else, like that, right? But again, since you don't really care about else because it's going to be the else by default, so down here we can just ask again, because once you break out, then the loop terminates right here. Okay, loop terminates at this point prematurely. If that's not true, then you keep guessing. So what do I do? Well, I have to do the same thing again. I can copy this line 16 here and do one more time. So you can say enter a number, or you can say guess again. Okay, and then that continues until you get the magic number, and you can give it a hint if it's you can do more, right? If it's too high or too low, you can say lower, higher, until they guess the number. So if this works correctly, and if you run this program, if you type in like 8, I'm going to keep guessing until I find the correct number to terminate this game. And the 7 is the magic number. So again, you see that now it terminates the game because I found my magic number. So here I'm using the break to exit out of the loop. And this one here we can say 7 is like the sentinel value, although it's not really true in this case, because I'm not comparing that sentinel value. That's one way to write it. Another way is if you want this program to exit naturally, you would put the condition test, you would test the condition right here instead of the word true, right? Because now I'm causing this break and then I exit the loop prematurely. So instead of doing that, you can say, instead of true, I put here the condition is this number, okay, the magic number, replace that with this, while this is not equal to the guess number, right? So you could say not equal here. Well, that's not equal, then you keep guessing. And this is one of the reasons you you can do that. I mean, lots of ways. This is just one way. You can do this way. You can use the variable here. It says done. Okay, done or not done, and so on. So when I do it this way, I don't need the break here because the break is redundant. But now I don't want to display this every time because once I matched the number, I will print congrats, and then that's it. If I don't put the else part, then it's going to get printed again. It's going to ask for another number, and then it ends the program in a really, really weird way, right? So it wouldn't make sense. I mean, just to see that in action, for example, if I go and save as is, and if I run the program, okay, so down here, if I type in like 5, you see that it keeps asking for the number. Clear this up. I'll do it again. So if I type in 5, right, that's not correct. So if I go 8, it's not right. If I go 7, and red, so it didn't print the number. It exits out, but you don't see anything there because after 7, it matches. I mean, while it doesn't match, keep going. Once I matched it, then it exits out. Yeah, so it didn't get to print this again, but I didn't get to print the done here. I didn't see the congrats, right? And so I'm just so in this case, because it evaluates here, once it I mean I read it here already, it evaluates, and then it matches, it's done. Then you will never get this print statement. So now you have a problem because you have to rearrange this in a certain order again, and so on. So which is why this case is not really helpful in this situation, because that means you have to kind of do this twice again. You read that again, you read one more time here, you can check it this way. The other way is, instead of doing this, so usually you don't do that here. You put something like, you know, done, and then you put while not done, and then outside of here I put done equals false. Okay. So while not done, keep doing it, and then once you find the matches, it'll be similar to what I had earlier. I print that out. And then I'll set done equals true. And so now when you run it, 5, 9, 7, it will say congrats, and then run from the issue here, right? Congrats, it says done, but then you see that it guess again. And I have to guess again, and then done. Now the game's over. So this is like a side effect. So in this case, you want to use the else part here, which is why the else is important in this situation here, because you don't want to display that every time. You only display it when the condition is no longer true up here. If it's true, then I set my done variable to true, and then forget about this else part, and then exit the program. So this way you don't have the side effect, which is it's asking to read input again for nothing, right? So you don't want that. And then now if I run it, it should work as expected. So 5, 6, 7, and then congrats, done. So in this example, we say that the variable 7 is the sentinel value. In this scenario, there are many ways you can use it. The sentinel values is like you keep inputting data until a number is a certain number, like a negative number is a very typical one, or until you press Q for quit or something like that. Okay, and that's will be something like you keep entering some number until you reach a certain number. So for example, if I go and change this to say something like this, let me comment this out. And I'll do here, say I have a list of numbers. This is a list. We'll learn list later on. I mean, a list we just like that. Okay, this is a list. A list is called a reference data type. And we'll learn about the reference data type later on as well. It's really important. Very different from the non-reference type. So a list of numbers, when it's empty, there's nothing there. And then I want to do a while loop. I'll say while. You can have a number to put here. So you can say num is equal to, what should we say here? Equal 0, start at 0. You can say while number is not equal to -1. Okay, so the -1 in this case would be like a sentinel. You can put a 1 there, which I don't like. So usually, again, for best practice, put a variable here. Sentinel equals -1. And you can put that replacement here. Well, that's not equal that terminating value. You keep reading some numbers. So now I can say a num equals integer, right? Convert to integer. And then in here I put input, enter a number. You put here like a -1 to stop. Something like that. So the user knows when to stop. So once I read the number, and I'm going to add the number to the list. Yeah, this keeps happening. So you can add number to a list, but you don't add it when the number is not -1. You can say if num is not sentinel, then I want to add the list called numbers. And we'll learn this later, but you want to append that list, the number to the list. And so this code will keep you what happened here? It's not liking my code. What happened there? Let's see. Oh, colon over here. That's strange. Why is that? It doesn't like my if statements, and that's weird. I'll read that in, oh, I forgot to close over here. Okay. Yeah, I need to close that bracket, missing one. Clear that. Okay, so when I run it, it asks me to keep enter a number. It didn't say what number it is, but any number, right? I'll keep going until I enter a -1, and then that will terminate the loop, and I'm done. Okay. And if you check your the variable explorer, you see that the numbers, these are the old ones before we didn't delete from the cache, is still there. But you see the numbers now contains all the list numbers that I entered above, 12, 3, 34, 6, and -1 is not included because we did not include that inside here, right? If you don't do this, you just put numbers that append, it will add -1 to that list as well. If that's important, yeah, that's how you do it. But otherwise, this would be one of those scenarios where you keep asking a number or something to be entered until it's valid. So this is, again, called a sentinel because it's a terminating value that is usually not part of the data that you want, which is why I did not include that inside the data here. So that's typical for the while loop. I mean, this is not a Python thing. It's just the way it is for most loops. All right. You can also have nested loops inside other loops as well. This one here, I just have a while loop. And you can go even a step further saying, you know, right in here, instead of, before I add this, what if I just want to add, well, I mean, you can say something like, oh, I can think of an example. Once you enter a number, and then you can say, well, the number is yeah, you can do, I mean, just for the fun of this, you can say while the number is even, right? That means even, right? The number is even, and then you can add, right? So if it's even, and then I'm going to add the number to the list. Okay, and so at that point on, you have to keep entering this again, right? Because it has to keep going, and then put this way back it was before. So I enter a number, I read the number, and let's just say I only want to record even numbers, right? For example. Then, while the number is even, then go ahead and record the number and keep asking that until, maybe in this case, not a -1, but until a number is no longer even. I mean, you don't say here, but you just say 1 will automatically terminate the loop, and right? Otherwise, you will just keep doing. So to make that work, you have to put two conditions here. You can say, well, it's not equal to, it's not even, and number is not sentinel. But then it doesn't matter, right? Because once you get a -1, it's already a odd number. So it's going to exit out anyway. But if it's not an even number, you can do that. Or that, if both of those are true, if it's not even and it's not a -1, then keep doing this until one of those is true. If it get an odd number, it will exit out, and then it will put that in here and it will repeat the process again. Okay, so we'll see if that's true. So run the program here. Let me do it again. I'll clear my console here first. Okay, so enter a number. I put here 3, right? So it's still the outer loop because that is not an even number. I put 4. Now we go inside the inner loop here. I didn't put here, but you should say inner loop, right? So we're inside here now, and so you can see that the numbers yeah, so 4 should be in there. If I put 6, it should still be on. It should still be in there, in the inner loop. You should make some notes so we can tell. But once I put 7, I should be out of that inner loop. And if I put a -1, I should still terminate the program. And you see that I recorded the R numbers in here because of this part here. If I did not put that there, then you will see that it should only record even numbers because only numbers are recorded inside the even numbers here. But here I just say that record that as well. So if you remove this part, then you can only record even numbers. And so let's just say if I turn that off, Control 1. And I'll put a note here so we know it's inner or outer. So we put here outer. I put the inner. So where we're at in the code. Maybe I'll move this like down here or something. Okay. Oops. Right, so I'll clear my screen. Alright, so now we're in the outer loop. If I type R numbers, I will always be in the outer loop, and my number should not get recorded. Okay, so I put like 1, right, 3, 13, right, -5. This is always in the outer loop because it's a negative number. But once I put like an even number, you can see that now I jump into the inner loop. And as long as I enter even numbers only, those numbers will be recorded, and I'll be staying inside the inner loop until I either enter a -1 or a R number. A -1 will kick me out of the loop and the entire loops, right? It will propagate upwards. But if I put like an R number like 5 again, you see that I jump out back to the outer loop here again. I did not enter the sentinel value, so the loop will still continue on. And again, if I enter R numbers, those will be skipped until I enter a even number. And then to terminate at either location, a -1 will end that entire loop. And if I check my variables, then my data should be only even numbers. Okay? So all the odds are not recorded because we didn't record it. Because we say don't record numbers only when they're even numbers. So that's an example of a nested loop, a nested while loop inside another while loop. So that's the basic setup of the while loop. Here I've only put one statement and two statements in there. Usually it could be pretty long. Okay, I'm just showing you the simple way to do it, but you're going to have a lot of code inside the while loop. So just make sure the indentations are properly set, and then you cannot leave any line blank after the colon if you don't do any indentation. If you want to leave it or skip it, put pass, and then that will pass it, or skip it. The condition here, I'm using a single condition. It can be compound conditions as well. You can have, like I did here, this is a single condition. This is a compound condition, right? Because there are two of them, two or more. And I combine both of those with the AND, the logical AND operator. So the result will always be a single true or false, even though I have two compound statements here, because the entire result here will always be true or false. Okay? Because each of these will be evaluated separately, and if you AND those together, then you get either true or false, and that will terminate. That will decide whether the loop should continue or not continue. So this is an example of using a Sentinel. Some other loops that you may want to use is a counter. Okay, so this is using a counter. And this is probably more common as well. Say that I have a list, or even like a string. Okay, if a string of data. So put it here, like happy day. Okay, and if you want to print every character in that string out, character by character to the console, then you can use a while loop to do that. Then we need a counter to count each of these numbers, right? So initially we're going to have a counter starting at this position. This is the 0 position, all the way down to 1, 2, 3, 4, 5, 6, 7, 8 position, the index. So the length is 9 because it's always the index, the maximum index plus 1 is the 9. So you need to know the length of that string. So you can do something like this is equal to message, len, called the len function, message, that will give you the length. In this case it's 9. I'll just type length. And you also need the pointer or the counter to start counting from. So we can call that counter is starting at 0. And then to loop each character, you just say now while counter is less than, we started from 0, you can say less than length. Right? Because we're not including 9. So it'll be 9 minus 1. So that means it'll be only 8. Because once this reaches 9, then it's no longer true here, and we exit out. So this is the one-off. You have to decide here. Do I use 9 and then use the less than, or do I use less than equal to 9, but then I have to minus 1 over here? Okay, so you have to do one or the other. If you don't, you're going to have an error. It's going to have a out of bounds exception or error. So either way is correct. Just choose one or the other. So I'll do that, and then I will print out the letter out of that message. I mean the message letter. So you print the message variable, and then you just get the position of that letter, which is counter. So every position through that loop will be printed. So the first will be 0, so it will be H, and then after that, just make sure you have to increase the counter, increment it, otherwise you will run through the forever loop, right? After I print it out, then I want to add 1 to counter, so that it will increment through that loop until the counter is no longer true. It reaches 9, then 9 is no longer less than 9. So then it will exit out, and then we're done. So now when you run this code, you're going to see that every character is printed, including white spaces. Okay? And so you can say, okay, great, this is how I can actually access each character, and then once I access the character or the letter in that word, I can do something with it. I can compare it. Okay, if I ask you to, okay, find how many vowels are in this text, then this is how you do it, right? You compare each of these characters and compare this, is it equal to A or E or I or O or U? If it's not, then move to the next one. If it is, then what is that position and what is that letter? And then if it's a repeating letter, you add maybe the count to that as well. How many letter A's, how many E's and I's, and so forth. So things like that becomes really useful in the data world. Okay, like we just talked about one letter here, but think about finding people's name in the database. Okay. Any questions before we move on to the next topic, which is the for loop, which is a little bit confusing, but really, really powerful. Okay, so this is using the counter. This is a counter. The counter is this just counter. When you initialize data this way, like initialize my counter, initialize the length here. If you do some math operations, then you can also initialize some data here as well. So you can say like total is equal to 0, and maybe I want to count, how many letter A's are in this, right? This text, so that you can add that to the total. So you can say, print that A first, but you can say if message of counter is equal to A. If that is true, then total is total plus 1, right? So counting my total A's, and then once I'm done out of the loop, I'm going to print A count is equal to total. But then, of course, it doesn't like this because this is not a number, a string, so you want to turn that into a string. So when I run this program, I should get 2 because there's only 2 letters in the A and the text here. So this is a counter. What I'm doing here, I'm initializing these variables, and a technical term that they use in computer science or programming is called priming or prime read. Okay, this is called prime read or priming. That means just basically initialization. So if you get a term, prime your variables or do a prime read and then do a count or a loop. That's what it means, just to initialize your data. So you can see that we did a loop through this message here. So any container type of data types. String is a container type. There are many container types in Python. Like list is the one. We have sets, have dictionaries, we have tuples, right? Objects, and many more. All these are containers because they contain, multiple data in a single to a single variable here. But numbers are not; they're not containers because it's just a number. Okay, so this is just the while part. Now the next loop is the for loop. I'm going to go and create a new file. And I'm going to clear my cache out here so it doesn't slow my computer down. The computer is pretty old. I'm surprised it's still surviving. Okay, so let's create a new file in my File Explorer. Right click, new file. This is going to be the for loop. For loop.py. This loop is very powerful and can be really tricky as well. Because the for loop here, you're looping through, just like the while loop, you can loop through a range of numbers. Use that as a counter. Or you can loop directly using a container type, like a list or a string or an array type of data. And I'll just do one simple one here, and we'll take a break and we'll come back and we'll do it again. But the for loop syntax, the most common ones you'll see, and also illustrated in the book, is by using a range. Okay, so a range is it's a special function in Python that gives you 3 parameters. So I'll put here first, like the range. Inside here you have 3 parameters, or 3 arguments. The first one is the starting position, okay, the starting number. And these are always just numbers. The starting number, and this is the stopping number. And, sorry, not colon, should be a comma, sorry. And the third one is the, we call it step. How many numbers should you jump, right, from the starting number to the stopping number? How many steps should you take? Do you take 1 step at a time, or 2 steps, or 10 steps? Do you go in the positive step? Do you go backwards, right? You can go in both directions. And again, this is only for numbers. And so both of these, the starting and the step, are optional. Okay, you don't have to put that there. And this is the stopping number is the one that's required. So whether these all 3 are present or not can be really different in your code. So you will see a lot that you have a for loop like this, for, and then followed by a variable here. Okay, this variable will store the value, or will in this case, if you're using a range, okay, if it's a range, then your variable here, let's just say I, will be equal to, was set, initialized to the starting number here. So whatever the range starting number may be. Okay, and it says for I and range, and then here is what the range is. So you can see by default it only asks you for the stop number. Okay, if you put the stop number, let's just say 10, if that's all you do, then again the other 2s are optional. That means it will always start at 0. The start value will always be at 0, so that you don't have to put it there. It's by default. And then the default is for the step, it's always a positive 1. Okay, so you increase it by 1. So then that means I'm starting from 0. I'm going to count every number 1 at a time until 10. And the number 10 is not included, okay? It's exclusive. Because from 0 through 10, if you count it, including 0, you can get 10 numbers. So the 10 is the upper bound, and it's not included in the count here. So I will not be 10, I'll be just from 0 to 9. So if you print I, and it will print from 0 to 9, because next is 10. So that is the maximum number, and it will stop because the count is already 10 digits. Okay, so very straightforward like that. This is the default values, 0, and then step is 1. If you want to include the step, well, you have to include all three of them. You can't just do like, okay, 10 and then step 2. Okay? If you do that, it'll be completely different. It means I'm starting at 10, I'm going from 10 to 2. Well, this is already larger than 2, I'm done. Right? So there's nothing to print. So it will check the value, this number against this number here. Because the default is I'm stepping in the positive direction. Since 10 is already bigger than 2, I'm done. It's false. Right? So if you want to use a step, you have to include all numbers. So I'm starting from 0, and then the stopping is 10. I'm going to increase it by 2 every time. So from 0 plus 2, now I'm printing only the even numbers, including 0. Okay, and then if you want to go the negative direction, you just turn this step here in a negative direction. If you do like a -1, that means I'm counting in the opposite direction. So behind the scene, which we don't see, Python will look at the stepping number here. That determines the direction of the count. It might go in the positive direction or negative direction. If I'm going in the negative direction, okay, then I'm starting at this number, going until I reach this number. In this case, wait, 0 is already less than 10, so I'm done, right? Same thing. So in this case, if this is not incorrect, you should not see anything printed because it's already false, because 0 is already less than 10. Since I'm going in the negative direction, so you compare those numbers. But if I put like 20 here, then it's going to go from 20, count until 10. Again, the 10 is not included. So it will from 20 until 11, and it will stop there at 11. So you can see how flexible this is, and this for loop here. So what you see here, we're printing the actual values inside the range here, because range, again, only stores numbers. So you print the exact value from here. And before we take a break, you can rewrite this. So how would you rewrite this in a for loop? I mean, using a while loop. Exactly this one here. How would you do it using a while loop? So you need three values, right? 3 variables here. So the equivalent while loop will be something like this. You need one for the, again, just put here, I put start is at 10, I mean 20. The stop is at 10, and then the step is a -1. So you can see how people would favor the for loop because it's much shorter. And then I have to do okay, while, stop, right, is greater than, I mean start, or either way, start is greater than stop. If that is true, then print start. But then I have to modify my start. So in this case, I have to say start is equal step. Right? I have to plus the step. But the step is negative, so it's going to go the negative direction. Right? So if you do minus minus, you're going to go in the positive direction, and that's not correct. So be careful here. So let's see if this is correct. And I will turn off the for loop here, so it doesn't process that. It should just start from the 20 to the 10. And again, this way, it should not include the 10 because we didn't say equal to, right? So when you run this program, I get exactly the same result. Okay? So these are equivalent. This one here and this one here are equivalent. And you can see that, you know, I would prefer the top one, right? Really short. Much shorter. But it doesn't mean that it can't be done. here as well. I put it here. This could go up here. And then instead of 20 like this, I can do the same thing. I put here start, stop. So try to use variables anywhere you see unnecessary or meaningful. Okay, so do that. So what do you think is going to happen if I run this as is right now? What should I get? Am I going to get two sets of numbers, or just one, or none? What do you think?
I think one, because nothing breaks the for loop. Except does the for loop end when it's done?
Yeah, I think my expectation is that, right, you see the one set of numbers from 20 to 11, but you're going to see it only one time, right? So in other words, this will run, but this will not run. Why? Why do you think? If I run it,
Nothing to end the for loop, except the for loop might end itself. When it's
actually, well, it does run. Why is that?
no, it ended itself.
Mm-hmm.
So that's what happened then, right?
Oh yeah, right. In this case, it does run, right? Because I'm not changing the actual step. Yeah, I mean the start here. So it runs twice.
So if these were reversed, it would.
Yes, right. So if you do it this way, then you wouldn't. Right. So if you do it this way, then it will only run once. So there you go. Yeah, confusing. Because I'm changing the start value, I'm decreasing every time, so that actually changes the value here to 10, and then that point is no longer true, so you're done. Okay, well, we'll take a break. We'll come back and we'll continue on with more of the for loops. We're not done yet. More stuff with the for loop. It's fun.